All right, and we are back. So, if you watched the last stream, I want to apologize for the error that happened during it, that I just got completely stumped on. The issue is fixed. Looks like I was kind of on the right path here when I recognized that, row and column right here were incorrect. But what I did do is I made a copy of it, and I just took everything and just went into every file, held down Control-Z, undid everything, basically. And that should put it back into the state before we started. I really need to get this thing under source control. I will do that eventually here. So, we're just going to dive right into it. You might have noticed I'm not bothering with the camera today. I'm just not feeling it. So, let's obviously swap this up because this is completely wrong. Wow, column and row. And then also, we should be specifying the column first here. So do column, and then row. So this way, when we're feeding it in from here, it's truly getting the column, which is the X value there. There still is a little more that needs to be updated, though. So that was just in the game cell class. We also need to make one small update to the game tile class here. And it's just more to kind of clean things up. But right here, as you see, we're just doing new vector, taking the row and column. So the game tile was actually rendering in the wrong spot, but in memory, the values were correct. So this can really just be simplified to be, cell.position. Because, that's what a sane person would do. So then within the actual game itself here, the pathing screen, let's make sure that we're doing things correctly. We'll just do a quick private list here. Private list, game cell, and this will just be our current neighbors. Yeah, sure. We'll just new this up because this is mostly just for debugging, just to make sure we have everything correct again. Let's change this to X, and this will be clear. We'll come back to that in a moment. We want to keep the start, and D will be calculate. Let's just update F here to show the neighbors. So show neighbors. And then within here, let's add an argument check here for the key of F. And then in here, we will get the list of neighbors. So let's make a method here. So do private list game cell. I'm just going to get neighbors. We'll eventually port this out into the pathing manager, but we'll leave this as it is for now. So now we need to do, we need to pass in the game cell. So this way we can do a lookup here. So game cell. Sure. So now we need to loop through all these and check all the neighbors. Let's get a return value here. Okay, so return value list. So we'll do a check here. So if globals.map dot cells. Okay, that cells dot try get value. So we'll do cells dot try get value. We will pass in the string value here, which would be the game cell dot column, and then we add one, and it'll just simply be underscore game cell dot row, and then we need an out var, so out var cell to the right. And just for anybody who's watching from YouTube, I did not upload the previous video, which had all the mistakes in it. Okay, so then now we'll just add this here. So, or dot add cell to the right. And we can do the same thing, but we'll subtract one. And this one will become cell to the left. And then we need to get this, keep the original column itself by, so let's look at the cell above us, so we'll just subtract one. This becomes cell to the top. And then we'll do cell to the bottom as the last, plus one. Bottom. Alright, that was plenty painful, but now let's make sure I'm just going to look this over real quick here. So yes, we're getting the column to the right, that should be the cell to the right. The column -1 should be the cell to the left. Column stays the same, row. Alright, so now let's just get the neighbors here. So just neighbors will become get neighbors. So current neighbors equals get neighbors. And then the game cell that we're going to get, we'll just simply do globals dot map dot cells, and then we'll just grab the overworld selector, overworld selector dot column underscore overworld selector dot row, overworld selector dot row. And then down in our draw method, we'll just draw the neighbors, but let's also add the clear functionality as well. X, and then we'll just clear it out. Clear. And I think we'll also just want to clear it out here every time before we determine the neighbors, just to keep it clean. It's current neighbors. Overworld selector. We'll draw it on top of this. So overworld selector dot, no, damn it. Oh, yeah. Okay, sprite batch, that's right. We're just going to do a raw sprite batch draw here. So sprite batch dot draw. What's it? Asset manager dot instance dot texture. This will just, you gotta loop through each one of these. So for each neighbor, underscore neighbors. Move you up here. You just become the neighbor. Oh boy. I will type right eventually. And then, but real quick, I'm going to do an audio check because, you know, knowing me, I may have just probably been on mute the whole time. So real quick, test. And we sounds great. All right. So, you know, we need the neighbor.position, and we will use the large X rectangle, and we'll just do like a dark yellow, green. Sure, yellow green is fine. So now, anytime there's neighbors, it should loop through all of them and draw them, and this will trigger when we press F. All right, let's see if that actually worked. Okay, that didn't work. Oh, yep, I completely forgot. There's one thing I missed. So if walkable. Yeah, we gotta check if it's walkable first to determine if it's a valid neighbor. Same for this. Yikes. Okay. Let's format the document. Now this should do it correctly. So press F. Those are all valid neighbors. Now I should only get here, here, here when I run this next, and this one should not. This is the moment of truth. Alright, so far so good. Yep. It's getting back only valid neighbors. Let's check to make sure corners aren't going to blow anything up. And right now I can... Oh, never mind. Yeah, I suppose I should check. That's okay. This is our tool. We can do it however the hell we want. Yep, those all look good. Let's go further down the map just to make sure that this isn't like... wait, that was right? Yes, that's correct. Okay, so now that we're able to accurately, truly this time 100% for real, determine the neighbors, I think we can go back to implementing the input pathing manager. Again, if you are watching from YouTube and you're not watching this from Twitch, you have no idea what I'm talking about, and that's a good thing. Okay, so within managers, we're going to... Oh, that's right. No, I didn't create it yet. I undid it, right? Yes, I did. So we'll do some of that boilerplate stuff. So be pathing manager. And then within our pathing manager, we'll do make it public. So we need a private static local instance. Pathing manager instance. That's right. We established we needed to know what a maximum amount of attempts that we would take at it. This one, there are 10,000, right? Yeah, is what we just settled on. Public static pathing manager instance. Instance no. Pathing manager, and then just return it. Cool. Alright, so the next thing we need to do is it needs to find a path, but before we get too carried away, let's just go ahead and go into the pathing screen, and let's just copy this get neighbors method. We're not going to get rid of the whole concept as a whole, we're going to get rid of this line. But I do want to keep this list of neighbors because I want it to just return whatever those neighbors are so we can still do some debugging in that regard. So let's have a method here to get the neighbors. So public list, game cell, get neighbors. We'll take the current game cell. Game cell. Oh, what am I doing? Oh no. I didn't delete it, did I? No, I just commented out. Oops. Just put it here. Current. Alright, so that should get us the neighbors. What we also need to do is, eventually when we support diagonal movement, we will also need to check, kitty corner to the left, top right. We're not going to support that yet. We will come back to that. It's actually a very easy change. The only spot we'll have to make a change is right here in this method to check if we're going to allow diagonal movement and just simply update basically these try get values to just do more. So we need a method that we can call that's actually going to set the current neighbors that are on this house, because those could change, right? I mean, technically it could change. So let's do that. Yeah, let's create a method here. So a public list game cell find path. Game cell starting cell game cell ending cell. And you track how many attempts we're making here. So attempts currently at 0. So now we need an actual method here that's going to what am I thinking of? Set the actual neighbors. So currently I don't think game cell does that. No. So we just need to basically update the game cell here class just to include a list and then also a parent, because we need to know what are the neighbors, what are the tiles that are surrounding it, and then once we start building up the path, once we reach the goal node, we can recursively reference that parent to determine what the actual path is. So here we'll do a public game cell. We'll just call it parent, and public list game cell, and we will have that just be neighbors. Just new it up. Yeah, so that works. So then within our find path method, we need to we're going to just use which heuristic? I cannot think of the name of this heuristic. I just know it's the column minus the column plus the row minus the row, the absolute value, and sum those two up. I apologize. Is that I'm gonna sound like a jackass here if I'm wrong, but is that Euclidean? Yeah, I don't know if anybody who knows who's actually like smart with math can leave it in the comments if they would, and I will be sure to give you credit. So heuristic. I will take game cell A, game cell B, and that will... Oh, hang on, I'm on the stream. Yes.
Oh, my bad. I didn't know.
Okay. Then we'll do a return math.abs, the a.column minus b.column plus the absolute value of row minus the row, a.row minus b.row. So this should give us a numeric value to determine how far away is whatever node we're evaluating to the end node. So when we start with our first cell, we're going to calculate the heuristic from cell A to cell B. Obviously, if it's the same, then there's zero distance and we've already found our path. So that's not what we're looking, and that's not what we're after, obviously. But anyway, we need a method that's going to... One moment here. I absolutely hate seeing red squiggly. It drives me insane. So we're going to need a method that's actually going to set the neighbors that we just added to the game cell class. So let's just create a quick method that'll do that. Or should we? Yeah, we're going to. Okay, so private void. I'm just going to set neighbors. And it's just simply a for each. Bye! Var item in globals dot map dot cells. Okay. Item dot value dot neighbors will be equal to get our method for getting the neighbors, so get neighbors, and item dot value. So it's going to loop through each one of them and set the list of neighbors. Which one moment. Just 1 second here. Alright, apologies. Anyway, where were we? Yeah, okay. Yep, so we're getting the neighbors, so now we actually are setting... We need to call this method to actually set the neighbors when we determine the path. And this actually shouldn't change, so maybe if we could add something that instance is called here that could actually just set the neighbors for the current map. I'm not sure. That actually would not work because if the map changes, then obviously that's going to change. This is not the most efficient way to do it right here, obviously. So let it just know that. We're going to switch this up so this way whenever we initialize a map, it's just going to find out what are the neighbors and then we never have to calculate it again. There's just no reason to do that. Okay, so we're setting the neighbors. Our temps are 0. Let's do... We need a list of open nodes that we need to visit. So we have a game cell open set equals new list. So now this will be the nodes that we're going to iterate through. So we need to add the starting node to that because that's the first one we have to check is what's the starting node, and the goal node here, like the ending where we want to get to. We still need to know what are its neighbors perform some heuristics on it, determine which one's closer, and this is using a star pathfinding. There are 1,000,001 YouTube videos out there that'll teach you way better than I could even dream to teach you on this topic. I only understand it from a very basic and fundamental level just to make a path work. So it's definitely a blind leading blind here if you're not familiar with these concepts. So I do recommend you go check that out as well. So we're going to set the starting node here, starting cell. We need a dictionary, and we'll just use the actual game cell reference as our lookup, and we need to determine what's called a G-score and what an F-score is. So the G-score, I believe, is we just set that to the heuristic, and then the F-score, what is that math again? Yeah, so we have to determine what the have kind of like a tentative G-score here. So anyway, let's just continue. So we have our G-score. It's new dictionary list game cell. We want to initialize the set the starting node here. Sorry, so. And then we need a dictionary for the F-score. So we have dictionary game cell int. Then we'll do F-score. New dictionary, and we will set the starting node, and that will be equal to the heuristic. Starting cell and ending cell. Alright, so for the starting cell, we are taking a look at what its F-score would be by checking the heuristic on it. And then now we are going to just operate on this open set. It should at least do one iteration at minimum because we added it. So we'll just do a while loop here. So the while open set count is greater than 0. We will store a reference here, so do current, we'll just set it to null. We need to set what is the lowest possible score here, which is just simply the max value of integer, so int.max value. So for each game cell node in open set, check if the F-score for this current node here. Yep, so the current node. So we'll do F-score. Oh man, I can't type. F-score. F-score. There we go. For the node is less than the lowest F-score that we're going to yeah, so obviously for the integer max, and then this will get set while we're iterating through them, and then yeah, so obviously the very first one is going to be less than the maximum integer value. Otherwise, if it was beyond that, this wouldn't even run in the first place. So, so if it's less than the lowest F-score, we are going to set the current node equal to the node that we're evaluating in the open set, and then we'll set the lowest F-score for the current node. Okay. So once we're looping through these and we've hit the ending cell, then we know we've reached the end. So this could just return at this point. There's really nothing else we need to do. So we can just simply do if the current is equal to the goal node, or ending cell. Apologize, I have one of my old projects that I worked on where I did this opened up on the side that I'm kind of rewording here, so bear with me while I use the wrong terminology. So we'll do console. Let's just write to the console here. So we're going to do a write line. Let's just log how many attempts we made. Total attempts. Just to get an idea what we're looking at. Attempts. And we will need to increment the number of attempts we're making, obviously, while we're in the while loop. Attempts. Okay, and then also we want to check if we're exceeding the maximum amount of attempts. So if attempts is greater than max attempts. One moment, I have somebody at the door. I will be right back. Okay, sorry about that. My kid decided to just ring the doorbell for really no apparent reason. Alright, so we have our attempts is greater than the max attempts. Then that's when we just return. We're just going to return null at this point. Or really, we could just return an empty list. Yeah, I don't really like returning null, empty. Whenever we're returning a list, I really don't like when that's done that way, because 0 attempts could ultimately mean, not attempts, but 0 could just is basically the same as null. And like when is it really necessary to delineate between 0 records returned and null? So we're just going to return a new list. It'll just be an empty one. New list, game cell here. So now what we need to do is determine the G score here. But it'll kind of be more just like a tentative G score. But since we're looping through the current one, that's right. So within inside this loop, we want to remove current from the open set. Oh, no. Open set dot remove, do the current one. We're also going to need to reconstruct the path. So let's just leave a comment for ourselves. Return and reconstruct path. Let's just return this as well if we don't get anything. Alright, so now we've removed that from the list, and then now we're going to loop through all of the neighbors here. So we'll do a for each, game cell, neighbor, in current dot neighbors. So we specified what the neighbors were up here when we set the neighbors. So through here we need to determine what a tentative G score would be for this. So it'd be int tentative G score would equal to the G score for the current, and then we will add 1 current plus 1. Alright, so if the tentative G score is less than G score dot get value or default for the current neighbor dot max, because obviously we don't need to evaluate it. Then we've got to set the neighbor to it. So then our neighbor dot parent becomes the current. So yes, we've constructed our path. We're working towards it. So where did it come from, basically? And then once we reach the end goal, we're going to do this list kind of in reverse here with the current, and we're just going to recursively check the parents until we find our final. So now we need to store the G score for the current neighbor here. So we have the G score neighbor will be equal to tentative G score, and then our F score will need to do needs to do a heuristic on the tentative G score. So it'd be the distance plus the tentative G score that we've set here. So we will do tentative G score plus heuristic, and then now we're going to check the neighbor to the ending cell. Let's see, tentative G score plus. Oh yeah, I need to specify. I didn't say that this is for the neighbor. Okay, so then we also don't want to add it to the open set if it already contains this neighbor. Otherwise, we will add it. Dot add neighbor. So that, I mean, aside from returning the actual path, this should do the trick here. So now this should have set the correct parent to find the path, and then we can just reconstruct it and just reverse the path. So let's just make a little method here to private list game cell reconstruct path game cell current. We need a return value here. List game cell path new list path. And while current isn't equal to null, we will add it to the path. Current, and then the current will be equal to the current dot parent. And then we will simply do path dot reverse, and then just return the path. So now we need to reconstruct the path. Yeah, I think we just call with the current cell, because the current cell would be the ending node, so that means we've determined that this is the ending cell, and then just recursively look it up and then just simply reverse it. So now we should be able to just do a return, reconstruct path, and we will pass in the current. So that was quite a bit. There's probably a chance a mistake was made at some point in there, I have no doubt, but I think we're at a point where we can at least start drawing a path and see how close we got it here. So we'll go back to our pathing screen. We'll keep the current neighbors list, but let's also create one for a path. Excuse me, we'll just do path. And then when we want to actually determine when we want to actually get the neighbors and display them, we will, not neighbors, when we want to actually calculate what the path would be. So one thing we'll want to check here is that the goal node is not, they're not just both equal to the same thing, because obviously there's no path to find if you're just setting the starting node on the same as the ending node. So we need to also, we also need to keep track of the starting node. I suppose that probably would have been logical to do first. So let's do private game cell starting node, and that will be equal to null, and ending node. I should really be consistent. Cell ending, cell. Okay. So I'm on the pathing. Yeah, so we need to set the path start, so we'll check for B in here. And then the same way we determine this here, we can do here. So the starting node will just be simply this. And then C, oh yeah, starting cell. We need to do the same thing for C, except for setting the ending cell. Yeah, it's the same logic there. Let's remove this. I don't want to get all confused here. And then when we clear, we also want to just clear out the starting cell and the ending cell. And then to actually calculate the path, we're going to do that here. So now we just set the path, a pathing manager dot instance dot find path. And we'll do starting cell and ending cell. However, we should also check no and underscore ending cell isn't equal to null, and also they're not equal to each other. And then we will actually calculate the path. So then we want to loop through the path here. For each our neighbor, or no, not neighbor, cell in path. I do sprite batch.draw, not dispose.draw, asset manager.instance.texture, cell.position, globals.rect.large, x, and what color should we make these for the path? I think it should just be green. Just green, sure. Might be a little bright, but that's fine. So as long as the path has values, so we don't need to do any null checks here, that should be fine. But we also want to indicate where the cell, starting and end node is. So we'll do starting cell if isn't equal to null. Let's copy this up here, except we're not going to use the same rectangle in color. What should we use for this? Let's use Dwarf 1 and Dwarf 2. Make this guy blue for the starter. Same thing for ending cell. We'll make this Dwarf 2. And let's make you also blue. Why not? No, let's do different. Dark red. Should make this dark blue too. Dark blue, yeah. Okay, so if all of this was done correctly, oh wait, no, we need to clear out the path too. So underscore path dot clear. I will be shocked if this works on the first run, so I'm not hopeful, but I guess we'll see. Let's see what it looks like. So pathing. Okay, so we want to set our path start to B, so I put the dwarf there, and then our end was C. I see what happened here. I think I see. Yeah, so the overworld selector, ending cell, starting cell, they're drawing in the right spot, right? Yeah, starting cell, ending cell, we're using those positions. Oh, duh. Pathing, so we'll set B and C. And let's just see if it figures out the path here. So what was it? I think it was, what did I set it to again? Yeah, F, that's right. What is D? Oh, no, we want to do D to calculate the path. Calculate path. And then this should be D, and then F. Yeah, I removed the show neighbor stuff. Well, hopefully we don't need to do that. We'll go back and implement it if this works, though. Okay, so we have B and C. Let's see. So we press D. Does it calculate the path? Oh, look at that. It does. All right, so let's clear it out. Let's try something a little bit longer. So B, and let's go here, and we'll press, what is it, D to calculate the path? Yeah, so far so good. It's looking all right. So let's get back to putting the neighbors back in there, just so we have it. Show neighbors. So that was F. So in here we'll do current neighbors dot clear, and then current neighbors will equal to pathing manager dot instance dot get neighbors, and we'll just get this cell. Now, instead of doing these lookups, it almost would make sense to just do it once, but that's fine. There's only one of these events that can fire off at the same time, so let's also make sure I didn't break functionality for that, and let's remove these. Switch it to E. We'll clean it up. Alright, so let's make sure E validly gets the neighbors. Cool. Oh wait, no, yep, there you go. So that's finding the neighbors correctly. X to clear it all out. So let's go down to like here. And let's make sure that it can do a long one and we're not blowing past the number of attempts. Because I did set it up to log the number of attempts, and that should give us a general idea of how much it can handle, or if it's incalculable, it's also possible too. So path end, D. Yeah, so 5,305 to go across the entire map. So I could see we would need to kind of just dynamically size this thing. Especially once we start adding diagonal functionality, that's even more that it has to search and determine. So let's also just be 100% sure this path would technically work. So far, so good. Yep, looks good. All right, well, I think that's, we can just call it here. I just wanted to make sure we got pathing, at least just kind of a start, or at least how to identify a path down. We'll add another option here, so this way we actually animate to the next one and moving around, and then we can bring this back into the game screen. One thing I forgot to do, I suppose since we made some slight changes, we should make sure this screen still works. It would help if I didn't get stuck right away. Okay, there we go. So now I go up here, press space. Okay, so it looks like it may have broke something here, but it's also possible I have row and column flipped in this as well. In any event, it does seem to be picking up that I can't move to specific tiles, but yeah. Weird. Yeah, I'm not sure what broke there, but that's fine. This was just kind of just to get the basic proof of concept going. So thank you for watching, and if you're watching from YouTube, be sure to hit like and subscribe, and bye for now.